Hello everyone, my name is Zhepei Wei and I'm a master's student from Jilin University. In this work, we introduced a novel framework, namely cognitive knowledge graph, to unify the symbolic and the continuous knowledge representations for machine reasoning. This presentation will go over the following four parts, so let's start with the background. Symbolic reasoning methods such as expert systems are believed to be reliable and interpretable in solving inference problems of specialized domains. However, these rule-based methods are difficult to generalize because obtaining a comprehensive set of rules from human experts is costly and time-consuming. Recently, continuous knowledge representation models utilize the distributed representation of a knowledge graph for machine reasoning tasks such as knowledge graph completion, in which the models could generalize from known facts to unknown or unseen but probably true facts. However, such models can only represent and reason about multi-relational data in the form of triples instead of if-then rules that represent logical consequence, and thus have a limited interpretability. So our motivation is that can we unify symbolic and continuous knowledge representation techniques to perform complex inference tasks? To answer the general question, we have to firstly find solutions for the following two questions. The first one is how to combine the rule and KG, and what will we get by doing this? But before answering this question, I'd like to first answer the second one instead. That is, what kind of complex inference task we are concerned in this work. So in this work, we introduced a novel reasoning task, namely the cognitive inference problem. With a large-scale knowledge graph and a moderate set of if-then rules as preliminaries, we focus on such situations where observation leads to conclusion based on the cognitive knowledge, which is essentially different from the traditional KG inference problems such as link prediction. To solve the above problem, we first introduced the cognitive knowledge graph, namely CogKG, and then developed a reasoning inference paradigm based on it. Briefly speaking, CogKG is a graph that expresses relational facts and expert rules in a unified framework. So obviously, a possible answer to the first question could be CogKG. Now, let's back to the motivation. After answering the above two questions, we can now convert the general motivation to a more practical challenge, that is, how to use CogKG to solve the cognitive inference problem. This gives rise to the CogInfer, which is a novel reasoning paradigm based on CogKG. Here we briefly introduce the workflow of the CogInfer. First, we perform knowledge representation learning on the CogKG and obtain the distributed representations of nodes and edges. Then for each observation or query queue, we create a corresponding infograph by iteratively identifying the closure of the involved rule nodes and entity nodes. The infograph is a small subgraph of the background CogKG, where the entity nodes in this graph are particularly categorized into two sets, namely known entity set and unknown entity set. Lastly, we perform reasoning on the infograph through applying accurate rules or link prediction with the learned distributed representations to predict the unknown entities in the infograph, and reports the conclusions with certain relational triples or rules as a decision path. In summary, we first introduce a new challenging machine reasoning task, namely cognitive inference problem, and then to solve the problem, we propose CogKG and CogInfer that unify the symbolic and continuous knowledge representations for machine reasoning. We are still working on several key points, including data collection, cognitive knowledge graph construction, and the practical implementation of the CogInfer framework. Thanks for your attention. If you are interested in our work, please scan the QR codes to learn more, and you are more than welcome to contact me for further discussion. Thank you.